Hello everybody. Now we are going to see about method overloading, static members and nesting of methods in Java. First let us see what is method overloading. We know what is a method. So generally a function is called as method in Java. What is overloading? The literal meaning of overloading is additional task given for something. Say for example, you have a lorry which has the capacity to load maximum of 5 tons. Suppose if you are going to add additional 1 ton to it, it becomes overloaded. So the same concept relies in Java also. Method overloading comes under the concept of polymorphism. You know what is polymorphism? Taking more than one form. So a method which is going to take more than one form is called as method overloading. Now while you are creating method overloading, the methods will have the same name. Instead of having unique name, method overloading will have the same name. But it will have different parameter list, either the number of parameters or the parameter type, and also the definition of the methods will be different. So why we go for method overloading? If we want to perform the same task, the similar task with different input parameters. Say for example, you want to calculate area of a circle, you want to calculate area of a triangle. Both is going to calculate the area but for different shapes. So since it is of different shapes, the formula will be different. So what we can do for circle, you need only one input, and for triangle you need two inputs. So that's what here we say it is overloading. You are going to calculate area for different formula, right? So while you are going to call the method, since it is having the same name, how it is going to decide, how the compiler is going to decide which method to call is based on the method name, number of parameters and the type of parameters. Remember that the method overloading is called only based on these three, but it doesn't depend on the return type. So one method may have the return type as int, the other may have float, but it does not depend on the return type while it is calling. It calls only based on the number of parameters, the type of parameters, and it is going to decide. Say for example, we are going to calculate the area. Here in this example, so we have calculation of area for a square and for a rectangle. See here, both the methods have the same name as area because it is going to perform the similar task calculating the area. But the formula is different for the square where it needs the side, only one side. So it is int a, and the formula see here it is a into a. So area of a square is a square. Then once when you are calculating the area of a rectangle, you need two parameters, length and breadth. So it is L into B. Now see here, while you are calling, we have created the object as C. While you are calling, you are passing one parameter, that is 5. So which method will be called? It calls the method that has only one input, only one parameter, that is 2. It is an integer. Then when you are calling C dot area of 5, 6, you have two parameters 5 and 6. So automatically it calls the second method. Actually first it verifies the first method, but the first method is having only one parameter, so it omits that and the control comes to the second method and calls to calculate area of a triangle. Note the output. So area of a square is a into a, that is you have passed 5, so the output is 25. Then area of a rectangle, you have passed 5 and 6, so 5, that is L into B, that is equal to 30. Now there is another example. Assume that we want to calculate addition of two integers, addition of three float numbers, and I want to add 0.5 to a float number. So totally we are going to have three methods. all the methods are going to have the same name as add. Why we have given the same name? It is method overloading. It is going to perform the similar task. What is the similar task? Addition is the similar task. So it's going to add. What it is going to add? See, in the first method it is going to add two integer numbers a and b. In the second method it is going to add three float numbers a, b and c. In the third method, it is going to add 0.5 to the value of a. So see the calling part in the main. We have created the object as a. If I give a dot add of 5, 15, it will call the method which is having two parameters and both the parameters are integers. So automatically it calls the first method. Once when you are calling a dot add of 9.0, first what it will do, it will check the first method. First method is going to have two parameters, both are integers, so it will not call that. Then it comes to the second method where you have three parameters, even that doesn't match with the number of arguments. So automatically it comes to the third method. It checks whether it has only one parameter. Of course it matches. Then the type of the parameter is also float. So it decides to call the third method. What about add of 5.5, 6.3, 7.0? It is going to call the method which is having three parameters. Both, that is all the parameters are float type. Now if you see the result, addition of two integers 5 plus 15, 20. Addition of three float values is, that is 5.5, 6.3, 7.0 gives 18.8, and addition of one value with 0.5, that is 9 plus 0.5 gives 9.5. So here if there is no match, then automatically the compiler comes out without calling any method, right? So only if it matches, it is going to call that particular method. That is your method over. Now let us see what is static members. You know the meaning of static. Static means rigid. It will not move or it will not change. That is the meaning of static. So static members. What is static members? Member of a class can be either a variable or can be a method. So both the variable of a class or method can be static. So this, once when you declare a method or a member of a class, that is a variable or a method of a class, it is common to all the objects. It is not, it is common for all the objects. Why we say this is, see, whenever you are creating the object, separate memory will be allocated for the methods as well as for the variables which are residing within the class. But in static, no separate memory will be allocated for the static members. Once when you are creating the first object, the memory will be allocated. When you are creating the second object, third object, no separate memory will be allocated for the static members. So either it may be a variable of a class or it may be a method of a class. Once when you declare it to be static, only once the memory will be allocated. So then how you are going to access it? While you are accessing the normal methods, members of a class, you will use the object name and the dot operator. Here it is not possible because the static members doesn't belong to the object but it belongs to the class. So you have to call only with the help of the class. So it is called as sometimes class variables and class methods instead of instance variables and methods, right? So you will call the static members as class members, not object members. It is class members. That is, generally we call the variables inside the class as instance variable and the methods. But here it will be referred as class variables and class methods instead of instance variables and methods. What is the syntax behind static members? Once when you want to declare any variable to be static, include the keyword static followed by the data type and followed by the variable name. When you want to declare a method to be static, you have to give the keyword static followed by the return type, the method name followed by the parameter list, and it will be followed by the definition of the. Now, once when you declare a method to be static, you have to look into certain rules. What are they? Calls only other static methods. The static method can call another static method. It cannot call a normal method, right? And it can access only the static data. It cannot access the instance variable. It can access only the static variables, that is the class variables. It cannot be referred with the help of this operator and the super keyword. We'll see what is this and super in the next presentation. So these are the three main points you should remember once when you are declaring a method to be static. Now let us see a simple example. So here I have declared one variable as static, that is count, and I have another variable a which has not been declared as static. So here count is a class variable, a is a instance variable, and I have a method called counting. I have declared it as static. Now check the definition of the counting method. It is accessing the count variable. What is count variable? It is declared as static, that is it has become the class variable. So I am going to increment the count. But when you come here, the next statement, a is equal to count, it is an invalid statement because a is a normal variable, that is it is an instance variable. So counting is a method which has been declared as static. So it can access only count but not a, because a is an instance variable. So it's not possible for it to access this a inside the counting method since it has been declared as static. And I have a display method to display the count value. Now let us see the output of this program. See here I have created the object S1, right? Now if I call the method s1.counting, it is an invalid statement because counting is a static method. It cannot be called with the help of the object name and the dot operator. It can be called only with the help of the class name and the dot operator. Now see, after that I am giving s1.display. So I have created s1 object. I have called the method counting with the help of the class name dot operator, and now since display is a normal method, I am calling it with the help of the object s1 dot display. See the output object number 1 created, that is your count value is incremented by 1. Then when I am creating the second object, I am calling the counting method again. So what happens? The count value incremented by 1, so it becomes 2. So generally the normal method will reinitialize the instance variable, but here once memory is created for an static member, it will remain as it is for all the objects. That's what it is incrementing the count variable. So see the output object number 2 created. Then I am creating the third object and I am calling the counting method again. So already our count value has become 2. Now it will become 3. But when you are incrementing the value of a, it will always be 1 because every time when you are creating the object, the memory for the instance variable will be allocated freshly. Whereas for static, once if the memory is created for the first object, it will be there for the subsequent creation of the objects. No separate memory will be freshly created. That is the concept behind your static. Now we are going to see what is nesting of methods. Already we are aware of the word nesting. Nesting is combining itself is called as nesting. Now when you are calling the method by another method of the same class, assume you have a class called nesting where I have a method called largest, where it is going to find out largest among two numbers and is going to return the largest value among a and. Now I have a display method. See, within the display method I am calling largest. So where the display method is residing, it is residing in the nesting example class. Where largest is residing, it is also one of the method of nesting example class. So this display method is calling another method called largest by passing the value 10, 4. This is called as nesting. Display method, it is a method. Now it is calling another method. What is that method? Largest. So this concept is called as nesting of methods. See, after creating the object n, I am just calling only display. I have not called the largest. Why? Because the display method itself is calling largest. So the control goes to the display method and display method will call the largest method. So the largest number is 10. That is the output. That's all for this presentation. Thank you.